Hey everyone, this is a new video around DataFlow functions. In this case, I want to show you how to use Cloudera DataFlow functions to efficiently load data into Hive tables into Cloudera Data Warehouse. So in the previous video, I showed you how to push data into Iceberg formatted tables using the put Iceberg processor. And if you didn't watch this video, I highly recommend you to watch it because this video is going to go through a lot of similar steps, but I will go much faster so that this video is not too long to watch. But in this case, I want to take the opportunity of this video to talk about a recently added processor, which is a Trigger Hive Metastore Event. This processor is super useful in our case so that you can push data into Hive using the object store and then letting the HMS Hive Metastore know that there is an update, there is new data available, and that the Metastore needs to be refreshed to take into account this new data. So instead of sending the data over JDBC or something like this, you can just take the data, push files directly in the underlying object store, HDFS, S3, whatever, and then just trigger the HMS by sending an event saying, hey, there is new data available, please take it into account. Because if you just push the data into the right locations of your object store, the data won't be available for your queries. You really want to have the Hive Metastore updated. So that's what I will be talking about today. In terms of how Cloudera DataFlow Functions is working and how everything is configured, again, this is very similar to the other video I did where I'm pushing data into Iceberg. So really, please have a look if you didn't, and let's get started. So I designed my flow here in a Data Hub cluster, and this is really straightforward. So let me just go through the different steps and explain what this is doing. So as with any DataFlow function, the starting point is an input port. I will receive an event triggered by AWS whenever a file is landing into S3. I want to be triggered by this file available, and then take this file and push it into my tables. So the first step is to extract the data I want from the payload of the trigger that AWS is going to send me. I will show you how it looks. Then I will fetch the file that just landed into AWS S3. And then I will be doing a partition record processor. The reason I'm doing this is that the table in which I'm sending the data is partitioned. So I need to be careful about this. And I want to partition my data into multiple files so that each file is going into the right location for the given partition. Then I'm pushing the file into S3 into the right location, and then I'm calling the trigger HMS processor so that I can trigger an event and let the HMS know about this new file available so that I can see it in my queries. So that's really straightforward. Here I have a generated flow file just to show you how it looks. So for example, before I go there, actually let me go in U. So as you can see, I have my default database, no table. I'm going to create this table. It's a managed one. It will be the same with an external one if you want to use an external one. You can notice here that the table is partitioned by a column grad, and this is basic format. That's it. But you could have a different format if you want. I really reused something here that we have in the documentation with some examples on how to create tables. This is running in CDW. I just need to refresh because I got logged out, but this is running in Cloudera Data Warehouse in Cloudera Public Cloud. So I have my environment, and then I have a virtual warehouse. They are stopped because I didn't run queries in quite some time, but those are the instances I'm using for running my queries with the U instances for running SQL. So I will create the table. Very quick, the table is created, and that's it. And if I select my data into the table, we can see I have no result. There is no record, there is nothing in this table. So here in the generate flow file, I'm just generating some data here. Let me show you here. That's what I want. So here, this is the data that I'm generating here. Student ID, first name, last name. I don't remember what this column is. This is level, and then major, and then grad. So level, major, and grad. So that's it. And as we said, we want to partition by grad. So here, the partition record, I'm saying this is a CSV. I want to write a CSV because in my case, I said that this is stored as text file. But if it was stored as Parquet, for example, I could use Parquet here. And I'm saying that I'm partitioning on the column grad. In the reader, I'm specifying explicitly the schema here. But obviously, you could use a schema that you specify in a schema registry instance if you want. But here, I'm just explicitly defining my schema here. We can see there is all of the columns here. And something that is important is that in the writer, I also specifically specified the schema, but I removed the partition column because we don't want the value of this partition column to be specified. This is something that will be in the path of the file where it's being stored in S3. So that's it. So here, if I run once, so I have my data here, and if I start this, each file is going to be split into two files because I have two different values for my partition column. So it's 2 files per node. I should have specified primary node only, but anyway. So here we can see I have 2 lines. And if I look at the attributes, I have an attribute grad with the value 2022. And if I look at the other one, I have just 1 line. And if I look at the attributes, I have an attribute grad 2021. So that's really what the partitioning is doing. And that's what we want. And then the data will be pushed here into a specific directory. Here I'm using a parameter, and the parameter here is equal to this because it's a managed table. So it's in my warehouse location in my AWS S3 bucket, manage Hive, the name of the table here. And then I have a directory grad equal and the value of grad that I'm looking using flow file attributes. So this will be specified by the value of the attribute in the incoming flow file. So that's what I'm using here. And that's it. So I will empty all queues. That was just to see the partition record processor. I'm removing all of this. Then I'm just pushing the data into S3, and then I'm using the Trigger Hive Metastore Event. I'm saying this is a put event, so new data is available. I'm specifying the path of the file I just pushed, and some properties like the database, table name, some Kerberos authentications, stuff like that, Hive Metastore, blah, blah, blah. Usual stuff. Something interesting to note here is in the fetch S3 and put S3 object, I'm using the default AWS credentials provider controller service, where I specify that I'm using the use default credentials to true, so that it's going to use the role associated to my Lambda, so that I don't have to deal with some access key, private key, and so on. So that's really what my flow is doing. Maybe one last thing here is that here I'm using Kerberos user service with a Kerberos password. It's a controller service where I can specify the username and password of the identity I want to use to interact with Hive in this case. So, sorry, here, the best practice would be to create in user management a dedicated machine user for this. In my case, I was a bit lazy, so I didn't do it. I just used my own identity, but you would probably want to use something like this. Create a specific machine user, and then you would use this as the CDP username. Don't forget the SRV underscore. And then you specify a workload password, and that's the password you would specify. In my case, I used my own credentials. So here, if we look at the value, this is my my own username. And that's it. That's it for the flow. So now if we go straight to AWS Lambda, there is a lot to say. And as I said before, this is very similar to the put iceberg function that I was showing. So I won't go into as much details as before. So here, very quickly, I create a Lambda. I'm specifying that it's Java 11. I'm specifying the handler. You can find this information into the docs, docs.cloudera.com, create a Lambda function, and you have this information here. You want to also provide the binary. When you go into Cloudera DataFlow, you can go into functions and download the binary for AWS Lambda. That's what you want to upload here. You need to put it into S3 and then specify here Amazon S3 location. You can't use the zip because it's too large. That's it. I'm using a layer. I will come back to this, but my flow requires some external files that I'm putting into a layer so that it's available in my Lambda. In terms of configuration, general configuration, I'm increasing the timeout to 3 minutes because in case of a cold start, the function is taking some time to start based on the runs I did. With the cold start, I'm about 2 minutes and 45 seconds. So I could even increase it a bit more to be safe. When it's not a cold start, the function is executed in a second. I increased the memory, but actually based on the runs I did, I could decrease this. Well, actually, no, I'm using the amount of memory that I'm setting. So this is good. You can see here when it's not a cold start, the execution of the function is actually below 1 second. So this is quite efficient. Let me go back here. So that's what we want. I increased a bit the ephemeral storage, and that's it. Something that is going to be super important is the VPC configuration. You want to have your Lambda running in the VPC of your CDP environment where CDW is running and so on. So I think I closed everything, but if I go to my environment here, you can see that, for example, the data lake here and the nodes, the Hive Metastore is running on this node here, the master node of the data lake. And this is running in this subnet of the corresponding VPC. Okay, so if I go in network here, we can see here the name of the VPC. We want the function, the Lambda, to run in this VPC. So here in my case, I took the VPC, then I selected 3 private subnets. All of this was already configured with my CDP environment. All of the private subnets have NAT gateways configured to provide access to the internet, so all good, and then security group. The only thing that is important to keep in mind for the security group is a small update. If I open it, and of course my session expired, Okay, so I'm connected again. So if I come back here, so yeah, if I go in my security group, something that I did modify is, well, actually, could show it to you from here. I added a rule here allowing all TCP access from 3 specific IPs here. Those 3 IPs are the specific IPs that are directly attached to the NAT gateway of my private subnet. So if you go see the VPC here, you can see PS3, PS4, PS5. You can see 3 NATs here, and you can see that there is one elastic IP that has been created for this public NAT gateway. You can take this IP and add it to your security group so that your function can access everything using this public IP. Okay, let me go back here. So that's on the VPC side. That's important. If your function is not running on in the same VPC, that will be problematic. In terms of environment variables, this is very classic. So access key, private key, and flow CRN. Flow CRN is the idea of the flow definition. So I exported the flow definition from here, right-click, download flow definition without external services. Then I go into Cloudera DataFlow, then Cloudera DataFlow catalog. And here I added my function. And here is the CRN with the specific version I want to run. So that's it. Then access key, private key are the ones associated to a specific user I created. So let me go back to management console, and then I will go directly to I will go directly to, user management here. And then I will go to here and filter for DFF. And I use this user. So this user, I created this machine user. I generated access key and private key for this user. And this user has a specific role, DFF, DF function machine user role, so that it can access, when the Lambda is running, it can access the data flow catalog to download the flow definition to be executed. So that's really the 3 mandatory information that you need when defining your function. Then all of the other ones are related to parameters that are specified in my flow, except those 2. So Kerberos file is to specify the path to the kerberos.conf file that I'm going to use for Kerberos interaction with the services. I will come back to this. And Java tools option is to specify some TLS configuration so that we can provide a trustor and the associated password. This is going to be used when we communicate over TLS to some services like ID broker, HMS, and so on. So you will need to put all of those files into a layer. And when you specify a layer, basically when you create a layer, this is a zip file. The zip file is extracted into /opt. So all of the files that are in your zip file will be in /opt. So that's why I created a layer with all of the files that I require, and Kerberos file is /opt/kerberos.conf. Here I have my trustor, /opt my trustor. Here /opt hive site, /opt core site. I think that's it. I have a few other files that are required by this little guy. I will show you in a minute. Then all of the parameters here. I have one more parameter that I stored into a secret manager that I created here. I created a secret that has exactly the same name as my parameter context. This is important. So same name as my parameter context. And that's where I added my sensitive parameter, CDP password. You could, if you want, add it directly as an environment variable into your Lambda. Okay, you don't want to go back. That's fine. Sorry. So you could directly add CDP password here, but I didn't want to show a password. So I created a secret in secret manager, and that's where I specified my CDP underscore password parameter and the value. In the permissions, you will need to update the role that is being created out of the box for you. So I added a few things there. I added a policy to give access to my S3 buckets to read and get the data. So that's what I was saying with the AWS credential provider in my flow. So it's basically going to use this policy as to read and write data into my bucket. So I added this policy, and I also updated the default policy. I added those permissions here. So for EC2, create network interface, describe network interfaces, delete network interfaces. This is required. And also permission for accessing my secrets. So list secrets, get secret value, describe secrets. And I believe, I believe that's it. So I added those permissions specifically to the default one so the ones related to network interface are because I'm running in a specific VPC, so it needs some permissions from a network point of view to run things there. And the one for secret manager and the one for S3 access. Okay, so let me very quickly switch to where is this window here? So here, that's the list of the files. So this is my flow definition that I uploaded, sorry, in the CDF catalog. Then I created a layer zip file with all of those files. So core site XML, hive site XML, kerb5.conf, the global trust store, and then 2 files that were referenced by the Kerb5. This is the binary that I downloaded, and this is the file I want to ingest that I was showing you with the generate flow file before. So if I go and I switch to where is it? Here. In the Kerb5 .conf file, I did remove the include dir at the beginning. I added here default domain, and I added those lines here with the IPs of my FreeIPA instances for my CDP environment. And then I updated those two pieces to reference /opt/files. As I said, those files I added into the layer. In Hive site, we can see the thrift address here, but the only thing I did is to here for the Kerberos principle here, before there was underscore host, I'm switching by the actual host of the instance where my HMS is running. And core sites, I switched the Ranger authorization server instance by using the ones in the data lake. I took those files from my Data Hub cluster, so those values were showing some Data Hub instances. I don't want my function to depend on Data Hub clusters when my Data Hub is not running, so I switched those URLs for some that are related to instances running in my data lake. That's it. I will go back to here. And I believe that's it. That's all I wanted to mention. So then I can go into tests. I created S3 payload tests. So this is what it looks like, what AWS is giving us. I just changed here the name of the bucket. And then here the key of the file. So I put this file into my bucket. This is to simulate the case where this file is landing, and that will trigger the execution of my function. And I specify the AWS region here. If I go in evaluate JSON path, that's those are the information I'm extracting here and that I'm using in the fetch S3 object to download the file and then put to send it to the correct destination. So just before I start the function, I just want to show you here managed Hive name partitions. There is nothing here because I dropped the table, so no data. So now I can start the test. So it's going to simulate the case where a file like this, it's the file I was showing with the 3 lines, is landing into S3 into this specific location, and this is triggering my function. So this is a cold start, meaning that the function didn't run recently. So it's going to execute the full lifecycle of the function of Cloudera DataFlow function. So in this case, it's starting the code of the binary that we provided. It's going to download the flow definition from the DataFlow catalog. It's going to inspect the flow definition to figure out what are the nars that you require for the processors that you used in your flow definition. It's going to download those nars from the internet, and then it's going to start NiFi, deploy your flow configuration, load your flow configuration, and then inject in the input port a flow file that will have this payload, and then execute your flow. You can drastically speed up the cold start, like make it shorter by uploading into a bucket all of the nars that are required by your function, so that it's not downloading all of those over the internet. But in this case, I didn't do it. This is well documented if you want to do it. In my case, it's not something I did. Also, a cold start is happening if your function is not running for more than 5 minutes. If your function is running every 5 minutes, for example, you won't have a cold start, meaning that all of the subsequent executions, it won't require NiFi to be loaded and download the nars and load all of this. Your NiFi is running and is ready to just process the data. So depending on how frequently you are expecting data, maybe you don't have to worry about cold start because this is going to happen just a few times. If you worry about cold start, as I said, there are ways to lower and shorten this cold start. Otherwise, there are some configurations in AWS to say, I don't want cold start. Please keep my function always running. Obviously, this is associated with cost, but that's an option. So here it's running. It's going to complete anytime now. We will have the details, and then I will be able to switch over to you, and so that's it. And now if I go here and I run the select from the query, I have my 3 lines. So this is working, the data is available here. And if I refresh here, I have my 2 directories with the different values for my partition column, and the files are here. If I go back here and I rerun the function, as I said, this is going to be much faster because we don't have a cold start anymore. So I'm going to do it a few times. So you can see here, it's running much faster, just a few seconds. You can see depending, sometimes it's below 1 second, sometimes it's a few seconds. So I did multiple times, and now if I select start from, I have much more data. I'm re-injecting the same file over and over, so this is the same data, but you can see that you have the data as expected. And if I look here, I will have more files. So that's how it's working. This is really similar to put iceberg in terms of what is required for the Cloudera DataFlow function configuration in AWS Lambda. But this use case was really to show you how you can use the newly added Trigger Hive Metastore Event, which is really useful because you can just push the data into the object store and then trigger the event with the Hive Metastore. And this is doing the job. You don't have to execute queries. You don't have to use JDBC to push data. So this is much more efficient and making flows much easier to manage. So that's it on my side. As always, thank you for watching. Feel free to drop a comment, and I will do my best to answer. Thanks again, and see you next time for a new video. Hopefully, I will be focusing my next videos on Cloudera Edge Management. Thanks again, and have a good day.